Well, okay. We're going to talk about 2015 BC6 today. All right, the series question. This was a pretty good question. Historically, I think kids did fairly well on the problem. The question the kids struggled with a little bit was in part B, which was using a geometric series to represent a function. So you got to pay attention to that. Remember, we love geometric series. If we can find them, we always want the geometric series. But before we get to that, let's take a look at this problem. 2015 BC6, part A, we're given a series for f. Okay, and the f series here we're given is x minus 3/2 x squared plus 3x cubed. And our general term here was negative 3 to the n minus 1 over n x to the n. Okay, pretty good series, not bad. We know in part A this converges on an interval. And so all we need to do is find the length of the interval. In other words, we don't need to know if the endpoints. Somebody was asking about this. This is the difference between the interval of convergence and the radius of convergence. So here we're just going to use the ratio test in part A. Yeah, don't let that wording confuse you in the stem of the problem. Let's just do the ratio test. So we have the limit as n approaches infinity of negative 3 to the n minus 1 plus 1 over n plus 1 x to the n plus 1 times n over negative 3 to the n minus 1 x to the n. Absolute value there. All right? And let's see what happens when all that simplifies. Negative 3 to the n, negative 3 to the n minus 1. Think of it in numbers. Negative 3 to the 12, negative 3 to the 11, right? So this is the limit as n approaches infinity of negative 3. All right, how about x to the n plus 1, x to the n? I think that's just x on my planet. And then n over n plus 1, we know that that goes to 1 as n goes to infinity. So here, what I've got is I've got negative 3x absolute value here. And we know this converges when the absolute value of negative 3x is less than 1. Okay? Or that means that the absolute value of x is less than 1/3. And what does that tell you? That's your radius of convergence. Okay? What would we do if this were an interval of convergence problem? We would have to test, right? Negative 1/3 to 1/3. And we would test those two endpoints. But we don't have to do that here. So we say the radius of convergence equals 1/3. Done with part A. Okay, in part B, and this is where, again, don't get confused by the wording in the stem of the problem. It says write the first 4 non-zero terms for f prime. Okay, so there's part A. If you need to take a snapshot of that, go right ahead. Here's part B. Let's take the series from A that we were given here in the stem of the problem, and let's take the derivatives. So remember our series with A was x minus 3/2 x squared plus 3x cubed. All right, and it says write the first 4 non-zero terms. So plus dot 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 plus negative 3 n minus 1 over n x to the n plus that. Okay. Now let's take some derivatives. It says write f prime the derivative. Write the first 4 non-zero terms. 1 minus 3x plus 3x cubed. Take the derivative. there. That would be 9x squared minus, figure out what the next term is, 27x cubed plus 81x to the fourth minus 243x to the fifth. I think you can name that tune. But what do you notice right here? Always looking for what? Geometric series. I got a geometric series with a equal to 1, r equal to negative 3x. Therefore, the sum of the series is a over 1 minus r. But the sum of the series is also a function. And that is the function to which the series converges between negative 1/3 and 1/3. That's the relationship, okay? Okay, so this is f prime of x. That's the function that the series converges to. So the sum of the series for a power series with an x in it is also, if it's geometric, on its interval of convergence, the sum of the series is the function to which the series converges. You may want to play that back at half speed. All right, now let's talk about part C. Write the first 4 non-zero terms for the series for e to the x, which of course you will have memorized by the time you take the AP exam. Oh, this is another one of these multiplying polynomial questions, isn't it? Right? And so we're going to do use the Maclaurin series for e to write the third degree Taylor for e to the x f of x. Oh my gosh, here we go. 1 plus x squared over 2 factorial plus x cubed over 3 factorial. I need a third degree. So let's go to f. Let's go x minus 3 halves x squared plus 3x cubed. I don't have to write anymore because I'm only interested in the third degree. All right, so let's do some algebra and see what happens here. And I think all of this should come out nicely. Now, I will try to do this carefully, but I'm doing this in one take. So here we go. 1 times all those. X minus 3 halves x squared plus 3x cubed. X times those until I get to a cube. Plus x squared minus 3 halves x cubed. Stop. X squared over 2 factorial times all of those until I get to an x cubed. Done. And then x cubed times that. No, because it's going to be x to the 4th. So when all of this comes together, we should have, let's see if anything goes with the x's. No. Does anything go with the x squared? It's got negative 1.5 and 1. So that's minus a half x squared. How about the cubes? I got a 3 and I got a minus 1.5. So that's a 1.5. And then I got a half. So that should be a 2x cubed. And I believe we have to use the Maclaurin series to write the third degree Taylor for g, which equals e times f about 0. That is the third degree Taylor for g. And that is 2015 BC6.